Yeah, so really it's just plug and play. As a final complication, you sometimes have to do an extra step, which is finding D, the slit separation. If you remember when we were doing experiments with diffraction gratings do not have little d written on them. What they talk about is the number of slits or the number of gaps they have per millimeter of material, and it's usually quite a lot. So if, for example, a diffraction grating has 600 slits or 600 gaps per millimeter, well, that's fine, but it's not what we want. We want to know the width of one slit or one gap. So this isn't a formula, I suppose it's just sort of numeracy. If you have 600 slits in 1 millimeter, then going back to scientific notation, like we did all those slides ago, that means we have 600 slits in 1 times 10 to the negative 3 meters, because milli is times 10 to the negative 3. Now, fine, 600 slits in 1 times 10 to the negative 3 meters, but we don't want to know that. We want to know what the width of one slit is. So if we've got 600 in that, then we're going to have 1 in that divided by 600. So you plug that into your calculator. Don't leave it as that. Plug it into the calculator, get some sort of number with a decimal point in it, and then you can crack on and use that formula or that formula. This is the last slide. Woohoo! It's been a long enough video, hasn't it? Right. So, thinking about the bright spots on the wall, this is kind of what they looks like a bit when we're playing with the lasers. If we're dealing with bright spots, then we know we're using this trilogy, don't we? Path difference is m times wavelength equals d sine theta. So this is the trilogy which applies to bright spots. And it's pretty common for there to be a question something like, what happens to the spreading angle, theta, when a smaller slit separation d is used? So we switch out the grating for one with a smaller slit separation. Well, do you remember what we were saying about higher physics? You can play with maths. If they're asking us to talk about what the spreading angle is going to be, the slit separation, let's not leave it there. I mean, let's say, well, actually path difference isn't important here, so we forget the chat about path difference, and then we'll just make sine theta the subject, so that's m times wavelength over d. And by making that the subject, it becomes really obvious what impacts that subject. So if the subject is the spreading angle, and it's saying, well, what happens if we use a smaller d?